Hello everybody. Today my presentation is about the impact of optimum protein quantity and quality during early infancy on future growth, body composition and obesity, and to reiterate the importance of it. Why protein is necessary? As you know, the protein is a very essential component of food and it controls the various functions of our body. As a chemical messenger, in the form of hormones and neurotransmitter, and as an enzyme, it acts as a biocatalyst for nearly all chemical processes of the body. It is also an important source of energy, though not always. Mainly the carbohydrate and fats are the source of energy, but at times of need, protein also is a good source of energy. In the form of hemoglobin, protein supplies the oxygen from the lung tissue to the body, and it has an important role in the immune response. As you know, most of the antibodies are proteins. It has an important role in the regulation of fluid and acid-base balance. Over and above, protein is a builder of the body in the form, it controls the growth, building blocks for construction and replacement of all cells. Not all proteins are the same. Proteins in food can differ in two critical aspects, mainly the quality of the protein, the type of protein and the amino acid they contain, and the level of each amino acids. Secondly, the quantity of the protein. Protein requirements is also not same for all the babies. For the low birth weights and the term infants, it is not the same. High protein intake is necessary for the low birth weights, and randomized controlled trials on low protein formulas and high protein formulas in this low birth weight and its impact on body composition with the low and high protein intake will be shown in later slides. Protein requirement is high in low birth weight infants, and it rapidly decreases during the early infancy, particularly from 3 months onward. Bangladesh has a very high percentage of low birth weight. In South Asia, the percentage is 25%. In Bangladesh, it is 22%. Worldwide, if you see that 18 million babies are born as a premature and low birth weight. And only in South Asia, it is more than half of 9.3 million. This slide shows the weight gain. As you see, during the intrauterine life, from 24 weeks to 36 weeks of life, the growth is very rapid. And this high rate of growth continues for a few months after birth. At the age of 24 to 28 weeks of gestation, it is 9 times higher than that of at the age of 4 to 5 months. Protein gain is also maximum during the rapid phase of growth. It is about 7 times higher during the 24 to 28 weeks of gestation than that of at the age of 4 to 5 months. Low birth weight infants need higher protein. Those who are born at 32 weeks, the requirement of protein is 3 to 4 kg per kg per day. Breast milk may not be enough for those, and supplementation of protein is required. Need of this high protein will not persist, and that will be the amount of protein will be same as that of term infant as they gain the weight of 3 to 4 kg. For the term infant, the ideal diet as recommended and the gold standard diet is breast milk. Exclusive breast milk will continue up to the age of 6 months, and from then onward, introduction of solid food is necessary. Now, high protein intake, the formulas with cow's milk, is it a problem? In this slide, you can see those who are breastfed, which is shown in this slide in the line of green, the weight gain is less than that of who are given with high protein diet. In subsequent slides, we will show the protein requirements of the low birth weight and the term infant, the high protein intake, clinical data and biomarkers, and randomized controlled trials of low protein formula and the high protein quality, and its impact on body composition with low and high protein intake. Here is a study, Darling study. You can see the infant fed on high protein formulas grow much faster than those who are breastfed. And this change particularly is noted at the age of third month. There is a strong association between accelerated rapid weight gain in infancy and its increased risk in later adult obesity and its adverse outcomes. We know the ideal weight of an at the age of 1 year is 10 kg. If it increases by 2 and 5 kg, that is, if the gain in weight is more than 12.5, there is 23% increased risk of becoming obese in later life. In this graph also, you can see that the increased risk of obesity. In Bangladesh, the World Bank database shows there is an increasing trend in the obesity. In 2003, it was 0.9%. In 2007, it is 1.1%. And in 2011, it is 1.9%. It is increasing day by day. It is an alarming for Bangladesh. So accelerated growth is becoming a concern. High protein intake influencing the metabolic consequences. So let's go through the protein overview in subsequent slides. Let us see what are proteins, how they are formed. All proteins are built from amino acids. Proteins are polymers built from building blocks called amino acids, and all of which contains an amine group and a carboxylic group, a variable side chain. Proteins are formed, as you can see, several amino acids combine together to form a polypeptide, and polypeptide chains folds into three-dimensional structure, and these polypeptides, one or more polypeptide chains join together to form a protein. Amino acids can be classified into three groups. The non-essential amino acids, these can be synthesized in the human body, and conditionally essential amino acids, these are also can be synthesized in the body except in certain conditions. And the third group is the essential amino acids. This cannot be synthesized in the body. This must be supplied through food. Among the amino acids, non-essential amino acids are 5. They are alanine, asparginase, aspartic acid, glutamic acid, and serine. The conditionally essential amino acids, which can be synthesized in body except in certain conditions, as I have mentioned already, they are arginine, cysteine, glutamine, glycine, proline, and tyrosine. The essential amino acids, there are 9 in numbers, cannot be synthesized in the body. They must be supplied through nutrition. And they are histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. Breast milk is considered as the gold standard of our protein quality. You can see the breast milk is rich in lactalbumin, alpha-lactalbumin 36%, lactoferrin 25%, and proline-rich polypeptides, none of them are present in the adverse effect of proline-rich polypeptides, you know, or we'll later on discuss. It is not available in breast milk. This breast milk is free from these polypeptides, proline-rich polypeptides. In this slide, you can see the difference between the bovine milk from that of breast milk. You can see in bovine milk, the lactalbumin is only 17%, and the glycomacropeptide, which is absent in breast milk, is about 12% in cow's milk. As compared to the human milk, bovine milk has a lower in alpha-lactalbumin and contains 12% of glycomacropeptide. Why breast milk is radically different from cow's milk in protein composition? You can see a human child doubles its size by the age of 4 and 5 months. A 3 kg weight baby becomes 6 kg at the age of about 4 and 5 months. But you see a cow's baby, they gain double the size by 6 weeks. The naturally growth is much faster in cows than in the human. So the need for protein is much more higher in cows, and each species produces the milk that is adapted to the unique need of their own offspring. The cow's milk is suitable for their calves, and human milk is suitable for the human babies. In this slide, you can see the percentage of essential amino acids in breast milk and of bovine milk. You can see the tryptophan is an amino acid needed for normal growth and brain maturation in infants. In bovine milk, it is much lower than that of cow's milk. Even disregarding the question of physiological role of specific milk components, there are clear differences in amino acids composition of the mixed proteins in human and bovine milk. Reasons dictate that humanized bovine milk formulas should approximate to the extent as possible to the gross amino acid composition of human milk. Protein composition. The high quality of protein in breast milk allows low protein quantity. The amino acid composition of cow's milk is different that of the breast milk, as we have seen in the previous slide. To match the content of amino acids A in breast milk, 2 units of cow's milk protein will be required, leading to the excess in the amino acids and the protein content. If amino acid supply of breast milk is matched with cow's milk, it becomes different. Human milk is a high quality source of protein. Breast milk covers all the needs of the protein for new term infants without any protein overload, whereas bovine milk has the overload of threonine and its branch chain amino acids. This metabolic disprogramming mechanism. The metabolic programming, either or disprogramming results can cause stimulation of insulin by direct release of insulin-releasing amino acids. This action results in activation of insulin release mechanism and increase in IGF-1 concentration with further increase in weight gain and an enhanced adipogenic activity. The ultimate final stimulation of insulin thus results in metabolic modification in the body. We have seen the biomarkers of accelerated growth, that is increased BCAA, insulin, IGF-1 and weight gain. Let's see on the GMP in next slide. Glycomacropeptide is present in whey as the byproduct of cheese making process. GMP is present in whey and byproduct of cheese making process. It functions inhibitory, it has got inhibitory effect on gastric ACE secretions and modifies the blood concentration of regulatory digestive peptides, and it has immunosuppressive and immunostimulatory properties, and it was proposed to induce satiety, but the effect not seen in human studies. So you can see the adverse effect of GMP on infant, which is absent in human milk but is 12% in bovine milk. And this different concentration of GMP in diet can cause gain weight. Infants in standard formula group consumed the most formula, although the amount didn't differ significantly between the groups, and they gained significantly more weight than did the breastfed infants. There is no significant difference between the infants in LAC or GMP or breastfed groups, nor were the significant group differences in increase in recumbent length, knee heel length, or head circumference. From this study you can see. This is a study on monkeys. In general, plasma amino acid concentration in breast milk were not significantly different from those in infants fed with alpha-lactalbumin supplemented formula. Plasma theanine, isoleucine, valine, methionine concentration in breast milk infants and the infants fed with alpha-lactalbumin supplemented formulas were significantly different from those in the infants fed control or glycomacropeptide supplemented formulas. So how to change this? Evolving from the conventional to the gold standard. Quality as well as content of the protein in infant formula need to be modulated to as close as possible to that of gold standard breast milk, that is increasing the higher alpha lactalbumin and tryptophan level and lowering the GMPs and lower protein contents. Breast milk has the advantages of higher alpha lactalbumin, tryptophan and lower glycomacropeptides that helps in evolving the conventional gold standard. Protein quantity in breast milk rapidly declines within first few weeks. As you see, the protein is very high in colostrum. In the transitional milk also it is higher, but gradually with the mature milk and subsequent mature milk it comes down to a level of 1.4 to 1.8 gram. And this adjustment is according to the need of the infant, newborn. The first few days the requirement is much higher than those that later on. The high quality of protein in breast milk allows low protein quantity. According to WHO, FAO and UNO expert opinion, the breast milk content amino acids is the best estimate of infant amino acid requirements. The primary limiting factor in reducing the total protein concentration in infant formula is the ability to provide sufficient quantities of amino acids. A low protein quantity is possible only if the protein quality is high. That is, the quantity of individual amino acids and the ratio between the different amino acids should be optimum. Protein concentration of breast milk is 3 times lower than that of bovine milk. Tryptophan is the limiting amino acids in low protein infant formulas. This is mainly due to the lower alpha lactalbumin content in the cow's milk, where as compared to the human milk protein. Maximum protein content according to the EC and Codex and US. The panel considers that based on the available evidence, a minimum protein intake of 1.8 gram per 100 kilocalorie from infant formula and follow-on formulas based on intact milk protein and 2.25 gram per 100 kilocalorie from formulas containing isolated soya protein is sufficient to ensure the adequate growth and development. Minimum protein content according to the EC and Codex and US formula standards is 1.8 gram per 100 kilocalorie. The panel considers that based on the available evidence, a minimum protein intake of 1.8 gram per 100 kilocalorie from infant formulas based on intact milk protein is sufficient to ensure the adequate growth and development. The European Society of Pediatric Gastroenterology, Hepatology and Nutrition recommendation you can see in this slide The minimum protein should be 1.8 gram per 100 kilocalorie and maximum 3 gram per 100 kilocalorie. High protein intake in infancy can result in unfavorable metabolic programming, as you see in this figure. In subsequent slides, I will talk about the protein requirements of the low birth weight and the term infants, the impact of high protein intake, its clinical data and biomarkers, and randomized controlled trials of low protein formulas and high protein quality, body composition with the low and high protein intake. Breastfeeding is unequaled way of providing ideal food for the healthy growth and development of infant. There is no doubt about it. It is the gold standard. What can be done? We can promote breastfeeding up to the age of 6 months. Not only that, exclusive breastfeeding for up to 6 months and subsequently continue breastfeeding up to the age of 2 years. If breastfeeding period is too short or not available, we should prescribe low protein formulas. What are the low protein formulas? Lowering the protein quantity is not enough because the amino acid profile much closer to breast milk and reduction of insulinogenic amino acids is required. Not only that protein should be lowered, but at the same time the quality should be maintained. There is a study comparing the growth of infant fed with low protein formulas, that is the high quality proteins with low protein, with WHO standard, and that have similar effect on breastfeeding. There is actually very little difference those who are fed with high quality low protein formulas and that of the breastfed babies. Infants receiving a formula with low protein and high quality grow exactly like that of breastfed infants. In the graphs you can see the difference of BMI at the age of 6 years among the breastfeeding low protein formulas and the high protein formulas. The red line you can see, that is with high protein, they shows that higher weight gain, but with lower protein and breastfed infants show almost similar results. There is no weight gain. It has been seen that infant fed with high protein during the first year faces a long-term risk. Obesity risk at 6 years is 5.6 times higher in children fed on a low protein formula. Talking about the long-term risk with feeding with high protein formula during the first year of life. Obesity risk at 6 years is 5.6 times higher in children than children fed with low protein formulas. Those who are fed with high protein formulas have 5.6 times higher risk than that of the low protein fed infants. Now let us see the protein requirements of the low birth weight and the term infants, the impact of high protein intake, and the randomized controlled trials between the low protein formulas and the high protein formulas. Body composition with the low and high protein intakes. Body composition of children is influenced by the protein intake during the first 12 months. You can see the difference, the same BMI but different body composition. In this graph shows the percentage of body fat between birth up to 60 months. At the beginning of the 6 months, the body fat starts decline. It is declining as you see. In the graphs, we see the comparison among the breastfeeding and low protein formula with high protein formulas that are responsible for the change of percentage of fat. There is no significant difference between the breastfed and the low protein formulas, but the problem is with the high protein intake. In summary, you can say the high protein need of the low birth weight is only until they gain the weight of 3.4 kg. Afterwards, the requirement will be same as that of the term infants. Accelerated growth. With accelerated growth, there is higher risk of obesity in later life. And short duration of breastfeeding can also result in obesity in later life. High protein formula, there is higher obesity risk up to the age of 6 years. And the meta-analysis shows children who were exclusively breastfed or received low protein formulas until 12 months have similar BMI until 5 years of age. What to recommend? We can take home messages and take actions like that. Promote breastfeeding. In many occasions, the babies are breastfed up to the 6 months, but after 6 months they abandon the breast milk and go to formula or some other preparations. But breastfeeding must be continued beyond 6 months of age up to the age of 2 years. If the breastfeeding period is too short or not available, in that case, recommend a formula with low protein. Don't recommend high protein follow-up formulas and growing up milks anymore. No cow's milk for infants. Let's wake up and stop obesity. Thank you for your patient hearing.